Now, statistics is a wonderful subject and an area of scientific research which deals with methods of collection, interpretation, and analysis of course, analysis comes first, and then interpretation of, data or information. However, often data practitioners fall into this trap that statistics is more like a wonder science and it can solve absolutely any business problem. It's important for data science practitioners to remember that statistics comes with a lot of assumptions and limitations, and it's completely up to the analyst or data science professional to use certain techniques and tools with their best judgment given a particular situation. So it's suggested that you have some familiarity with certain assumptions and the limitations of the different statistical techniques before jumping on any particular technique to solve a certain business challenge. One of the important aspects of statistics is that it's mostly used to analyze collective matters and not individual matters. For example, if you are trying to think about the relationship between expenditure and income of an individual, although it's rational to expect that with a rise in income, expenditure of an individual is, in general, supposed to increase. Now, that might not hold good or true for each and every individual. However, that's kind of the general trend that you might see from the data. And that's kind of what you would expect. That normally, in general, people tend to buy more or spend more with the rise in their income. And also, the other important thing to keep in mind is that most of the statistical decisions that are made mostly hold good in the long run. Now, there's this distinction between short term and long term that needs to be clearly made if you're a data science professional. And it should be very clear to you that most of the results might not have an immediate impact, might hold good if you're looking at the long term perspective of it. So there's this concept that, that's why most data science practitioners use the term that on an average, this is what the result looks like, instead of saying, attaching one particular value to every result or insight that they generate. Often it's loosely assumed that working with samples to generalize results for data science projects indicate that these samples might be representative, whereas in reality that might not be true. Often the samples might be biased, and this results in biased results, and they might not, kind of show the real picture, how relationships among the different variables exist in the real scenario. One other important pitfall is uh, often the comparison between apples to apples is not done, and that might lead to a lot of issues. Let's take this example where there's this clinical trial going on, and some individuals are being administered certain vaccines. Now, let's assume that around 40% of the total group have been administered a vaccine, and out of that, 10% of these people's health have deteriorated, whereas 15% of the individuals who did not even go to this clinical trial, they also suffered major health problems. Now, definitely 15% of the individuals who did not go to this checkup and who suffered health problems is a higher number than the 10% who have suffered health problems and who went to the clinical trial. Now, it would be wrong if we conclude that the drug that was administered was safer, because the two populations that we are looking at in these two cases are completely different. In the first case, where 10% people had a deterioration in health after a vaccine had been administered, out of the 40% people who were, who went for this clinical trial, uh, it's not the same as the 15% who did not go for this clinical trial. It might well have happened that the 15% who suffered health problems, even without going to the clinical trial, might have been individuals of old age, whereas the 10% of the people who suffered health problems were of a younger age. So it's very important to keep in mind what you are trying to compare against. One other important area in statistics is that of correlation and causation, which we will discuss in one of our subsequent lectures in more detail. However, it's important to bear in mind that correlation is not causation. Just if two things correlate, that does not necessarily mean that one causes the other. It might be well possible that the correlations between two things can be caused by a third factor which can affect both of them. For example, correlation between, let's say, sales of ice cream and the sales of sunglasses uh, might be positive. So, let's say the sales of ice cream increases as the sales of sunglasses do. This is pure correlation, but this doesn't necessarily mean causation. Causation takes a step further and gives a sense of direction where you know that a particular event has led to a different event. So often people, even most of the experienced folks in data science often kind of mess up or tend to confuse between these two terms. One other important thing is that of data transformation into a different form. If, for example, you are looking at percentage sales growth or increase across two different years, you might not be able to sum them up to show the total percentage change. Let's take this example where the sales of a particular product has increased by 10% in the time frame 2016 to 2017, and the sales has also gone up by another 15% in the year 2017 to 2018. Now, that does not necessarily translate into a 10 plus 15%, that's 25% growth in the sales from 2016 to 2018. We cannot add up the percentage in this way. Just because if you think about it carefully, the denominators in the two cases are not the same. There are many such pitfalls and many such limitations of statistics which a data science practitioner or an analyst needs to be aware of before trying to fit any of the technique or any of the measurements in any particular situation. Hope this was helpful, and stay tuned for more updates. It's a good idea to subscribe to our channel to get notified, anytime we upload a new video or a new lecture. Stay tuned. Thanks for watching.